The new experiment, velocity of sound by resonating bottle. Aim, determine the velocity of sound by resonating bottle. It is this resonating bottle. Resonating bottle, tuning fork, measuring cylinder, then vernier caliper, beaker, stand, etc. V square equal to 4 pi square L upon A into slope of the graph. V, velocity of sound in air which has to be calculated. L, length of the neck of the resonating bottle. Then A, area of cross section of the neck. Length of the neck L is equal to 3 cm. From this is mouth of the bottle and it is the neck. This length is 2 cm. Inner diameter of the neck D is equal to 1.9 cm and inner radius of the neck R equal to 0.9 cm. Means it is the experimental arrangement. Resonating bottle is hanged to or fixed to a particular stand. It is the beaker in which the water is collected for a particular time, and it is the tuning fork. These are the required observations for the calculation. Now, area of cross section of the neck of the bottle is equal to pi r square because it is circular and it comes out to be this. Now, we are using here the tuning forks of different frequencies ranges from 512 Hz to 320 Hz. Then resonating volume. While we are performing the experiment, we need of collection of the water whenever there is a maximum sound produced. As we are starting the tapping trials, and by losing the nozzle of the resonating bottle, the water starts flowing into the beaker drop by drop, and we are making the different trials for different tuning forks. For a particular volume collected in the beaker below the resonating bottle, the maximum sound will be heard, that is the resonance in sound, when the height of the air column of the resonating bottle and the frequency of this air column of the resonating bottle and that of the frequency of the tuning fork matches one another. At that time, the maximum sound will be heard through this resonating bottle, that is mean volume. We have to take the three trials, taking its mean, its square, and then 1 upon n square. It is n column, frequency of the tuning fork measured in hertz. It is its square column and then its reciprocal. Now plot the graph of V versus n square, 1 upon n square. This is volume of the liquid collected in the beaker for different trials of different frequencies, and it is the 1 over n square. Now after this we have to perform the calculation, and finally we have to calculate the velocity of sound by resonating bottle. While performing the experiment, we should know the basic knowledge regarding the tuning fork, tapping scale. Then what do you mean by the resonance in sound, and so on. Then the exact procedure for performing the experiment is nothing but measure the inner diameter of the neck of the resonating bottle with the help of vernier caliper, hence the radius of the neck, that is the height between neck. It is the neck, this vertical between mouth and that of this curved position of the bottle. This small vertical line is the neck of the resonating bottle. We have to measure its diameter with the help of vernier caliper. Then measure the length, find the equivalent length of the neck. Fill the resonating bottle with the water up to the neck. Means in this resonating bottle we have to fill the water up to this neck, means from this end to this end. We have to fill up this bottle with this liquid as water. hold the vibrating tuning fork when it is tapped on the rubber pad, then this vibrating tuning fork on the neck of the bottle and release the water drop by drop in the beaker itself. And then fix the stopcock. When the maximum sound will be heard here, then we have to stop falling this water. That is, we have to shut down this cock, and therefore we have to measure the volume of the water or volume of the liquid collected in this beaker. When the maximum sound will be heard, when the water is falling drop by drop initially while we are trying the different trials of this vibrating tuning fork, at that time the liquid from this end to this falls down in this beaker. Then this, after that particular surface of the liquid or height of the liquid, this after the upper surface of the liquid and that of the neck, there is a empty, bottle is empty, means here air column. Therefore, when the frequency of this air column of the bottle and the frequency of this particular tuning fork matches with one another, at that time there will be maximum sound will be heard at the, and that is nothing but the resonance in sound or sound resonance. While you are making the trials for this particular type frequency tuning fork, then as water falls down in the beaker or drops down in the beaker, the slowly the sound is coming, and when exactly frequency of air column and the fork matches with one another, we can heard the maximum sound. It is the exactly reading of the particular 512 hertz frequency tuning fork. Then the next tuning fork and so on, we have to this 480 hertz, 384, 324, 320 hertz. We have to take the volume for this particular 5 tuning forks and complete the observation table. Measure the volume of the water, which is the volume of the resonating air column, and repeat for 5 different forks. It is about the determination of velocity of sound by the resonating bottle. For this, we also know, for facing the online examination practical, we should know what is the specific dimensions of this resonating bottle, as we mentioned in these observations. What do you mean by tuning fork? What is the frequency? What do you mean by frequency? What is the definition of frequency? Then of which types of what frequencies you are using the tuning forks there, how you can tap the tuning fork, or how you can collect the particular amount of volume of liquid in this beaker, and so on. These are some basic questions regarding this practical as velocity of sound using resonating bottle. Velocity of sound using resonating bottle, and it is a particular result, and that result, that is velocity, obviously velocity of sound in air is measured in terms of centimeter per second. Your result should be with proper unit.